Hi, in this video we're going to consider a pair of related problems, and they will teach us when we should add probabilities and when we should multiply probabilities. In the first problem we're going to consider game A, and in game A one wins if one rolls either a 7 or an 11. And in the second game we're going to consider game B, where in the first roll one has to roll a 7, and in the second roll one has to roll an 11. And to solve our chances of winning either game A or B, we have to know something about the outcomes of rolling two dice. So let's look at that. One roll. Die 1 could be any of 6 different numbers, 1 through 6. And die 2, when you roll it, could be any of 6 numbers, 1 through 6. And that means there are 36 possible outcomes when one rolls two dice. How many of these outcomes are an 11? So, if this will be the first die, and this will be the second die. If the first die is a 5, the second die would have to be a 6. The only other way to get an 11 is if the first die you roll a 6 and the second die you roll a 5. So only 2 possible outcomes out of the 36. 2 out of 36 equals 1 out of 18. That's the probability of an 11. Pause the video to see if you can come up with a probability of rolling a 7. Okay, so we're 7. We need to figure out how many ways we can get a 7. So the first die could be, if the first die was a 1, we could get a 7 if the second die was a 6. If it was a 2, we'd have to have the second die a 5. If we got 3 for the first die, 4 would have to be the value of the second die. And similarly, 6 and 1, 5 and 2, and 4 and 3. So there are 6 ways of doing this. And so the probability of a 7 is there's 6 ways of doing it out of the 36. It's 1 out of 6. So probability of a 7. Okay, so now we figured out the probabilities of the 7 and 11, and now let's turn to the problems, games A and games B. Why don't you work on the problems and we'll trade answers. Okay, so what we've seen is that the probability of rolling 11 is 1 out of 18, and the problem of rolling a 7 is 1 out of 6. And so I've saved those numbers and put them to the right, and we're going to use these numbers. So the first question is, one rolls just once. One rolls just once, this is game A, and one rolls either a 7 or an 11. The 7 and the 11 are different alternatives. One outcome we could have gotten was a 7. Another alternative outcome is an 11, or we could have lost by rolling a 9. They're different alternatives. And when you have different alternatives, the rule is you add the probabilities. So for game A, you take 1/18, the probability of the 11, add the probability of rolling the 7, which is 1 over 6, and you end up with 4/18 or 2/9. Please pause the video and now try your hand at game B. So in game B, the 7 and the 11 are in a sequence. You have to first do the first thing, the 7, and then second do the 11, and then that sequence. And when it sequences in probabilities, instead of adding, you multiply. So it's going to be 1/6 times 1/18, which is a pretty tiny number, 1 out of 108. And so this video shows that we add in probabilities. Here's when we're adding them when we're dealing with alternatives. And we multiply. Here's what we multiply when we're dealing with sequences. And we'll use these in the problems in tomorrow's lab.